Okay, so hello. So last week, or the last lesson that you've watched, we left off on simple interest. So today we're going to start covering compound interest, and then the last portion of this unit will be future values, or also called annuities. So compound interest today. This is all part of assignment 3 as well, which has been emailed out to those of you who are in this class. But if you're in a different class, then you can always check in with your teacher what assignment this will be. So very few banks today pay interest based on simple interest formula. Instead, they actually pay interest by using a principle called compounding. And we'll look at the compounding and simple interest in a minute, but basically the difference between them is that simple interest grows very slowly. It's not an exponential growth, whereas compounding interest speeds up the process because it's actually an exponential function, and you'll see in the formula, and maybe that doesn't make a lot of sense to you, but basically with compound interest, we're making interest on our interest. So if you have an investment, so with simple interest, you get a certain amount of interest, so you get a certain rate over a certain period of time. With compounding interest, we have certain compounding periods. So the interest that we're earning continues to earn interest as well as the principal that we've already invested. So simple interest is interest on the principal amount. Compound interest is when your principal and any earned interest both earn interest. So for example, at the end of a year, you've earned a certain amount of interest. That interest gets reinvested and compounded. And in the following years, you're also earning interest on that amount. So just an example. So if we have $100 that's been invested at 10% annual interest, and we are getting paid simple interest, it doesn't really look like a huge difference in the first year for sure. In the second year, third year, even by about the 10th year, it's not looking like a huge difference. By 20 years, we do see a big jump. But if you look and see, if we have something invested in for 50 years, we have a huge amount of difference. So at the 50-year mark, our $600 that we would have made could actually be 11,739. So compound interest is your best friend when investing because time, like over time, that's going to grow exponentially. But you don't really need to know the theory behind this. It's just sort of like a fun, I don't know, this isn't painting my slide. Just pop it in here. Okay, so sorry, okay, there we go. So compound interest formula. So for simple interest, we had I equals P times R times T. Oops, sorry, it keeps doing this. But with compound interest, we have this formula where amount, right? So our amount is equal to our principal, bracket 1 plus I to the power of n. So in this case, we're not just finding our interest earned, we're finding our amount. So the amount being our principal plus the interest that's invested. So this formula accounts for all of the interest that we've been made plus the principal that's been invested over an amount of years. So n, so if you notice, we don't just have a T here or an R. Whoops, sorry, just keeps jumping. We don't have a T or an R, we have an I. So I is it's still our interest rate, but it's calculated a little bit differently. Well, in this case, actually, we have to calculate our I and our N. It's not as straightforward as simple interest because of the compounding periods, which we'll talk about in a minute. N is the number of years. So same thing, for our N, we're always in years, and for our I, we're always in a decimal form of a percent. But we do have to look at how to calculate it. So we're just going to start with this. We're going to use this formula. We're just going to look at a simple, no, I shouldn't use the word simple. We're going to look at a straightforward example of compound interest where we only have it happening annually. So we talked a little bit about this in the in simple interest. Annually means once a year. So compounded annually. So this is one time. Okay, so what we want to do is figure out, so it says find the accumulated amount, so A, when $4,000 is invested, so that's our principal amount we've invested, at 10%, so 0.10, per annum, so that's per year, annum means per year, for 7 years, interest compounded annually. So the key word here is compounded annually. So first we're going to say, well, our principal is 4,000 and our interest, or our I, is 0.10. And our N is however many years, and we have 7 years. So in this example, our I and our N are given straightforward in the question, and we'll talk about how if it's not annually, so if it's semi-annually or weekly or anything like that, this I and this N will change based on what my compound periods are. In this case, I only have a compound period of 1 time a year, so it's going to be pretty straightforward. So A is equal to P 1 plus I to the power of N. My principal amount is 4,000. My interest is 0.10, and my N is 7. So when I plug that into my calculator, and I wonder if I should, well, let's just say, so this is going to be 4,000, 1.10 to the power of 7. So you can type in 1.10 to the power of 7 in your calculator times by 4,000. Should I pull up the calculator? Let's do it for this one. Okay. Frozen here just a minute. I go to, I think I have my calculator up. Okay. So we had 4,000. 1 plus 0.1, right? 1 plus 0.1 to the power of 7. So we had equals, that gives us $7,794.86. Go back to our PowerPoint here. Oh, sorry. I hope it saved it. Oh, it did. Okay, good. All right, so we have our answer of $7,794.87. So that's compound interest. Now, you might also wonder, like, what if I had simple interest, right? So if I had P times R times T, what would that look like? So we know that I is equal to P times R times T for simple interest. So my principal amount was 4,000, my rate is 0.10, and my time is 7. So I could type that into my calculator, right? So let me just grab my calculator because I didn't have this written down, but I think it'll be interesting to cover. So 4,000 times 0.1 times 7. So that's the amount of interest I've earned. So I've earned $2,800. We're going to add that back to 4,000. So that's going to give me an amount of $6,800, right? So if I just invested this using simple interest, I'd only make $6,800. But using compound interest, I've made $7,794. So which one's better? For sure compound, but by how much? So we can take our compound interest, subtract our 6,800, so that's 7,794.87, take away 6,800. So that's a difference of $994.87. So compound interest is better by almost $1,000, right? By using compound interest. So it is interesting to see. We didn't have to do this. This was just extra. It just asked you to find your amount calculated. Okay, so let's move on. So compounding periods. I did talk about this a little bit in the last lesson. So yearly or annually is 1 time a year. Semi-annually is 2 times a year or twice a year. Quarterly is 4 times a year, makes sense, right? quarter, 4. Monthly, 12 times a year, because there's 12 months in a year. Weekly, there's 52 weeks in a year, so it's 52 times a year. And daily, there's 365 times in a year. There's also bi-weekly that's sometimes given. Bi-weekly, sorry, which is going to be 26 compounding periods. I think that should cover most of the ones that we're going to look at. So when we're looking at compound interest, so in the first example, we were just given a very simple I and N, right? But in order to calculate my I have to take my annual interest, so the number that was given, so in the last one was 10%, so I take 0.10, and I divide it by the number of times the interest is calculated per year. So if it's semi-annually, I divide by 2. If it's quarterly, I divide by 4, right? If it's yearly, I divide it by 4. Or sorry, if it's number of times interest, sorry, if it's quarterly, divide by 4. If it's daily, 365, right? That kind of thing. So you're always taking the number of years your investment times, for N, we times it by, and we'll look at lots of examples of this. And then if you're finding I, you're going to take your interest and divide by the number of times the interest is calculated per year. So here's an example. Interest compounded semi-annually. So semi-annually tells me 2 times, right? At 12%, so 0.12 rather, 8 years, so I have 8 years, would have 16 interest periods, right? And the rate per interest period would be 6%. And here's why. So to calculate my I take, right, so we talked about we take our rate, which is 0.12 in decimal form, okay, 0.12. We divide it by how many compounding periods we have. So this is semi-annually, so 2. We divide by 2. For N, I take my number of years, which in this case we were given 8, and I multiply it by my compounding period, so 2 times. So for my I in my formula, I have 0.06, and my N, I have 16. So depending on whatever my principal is going to be, this is the I and the N that I'm using. So you can notice that I don't just get to use my regular 0.12 like I would in simple interest and T equaling 8 like I would in my simple interest. I have to actually find a new I and a new N because it's not just done annually. If it was compounded annually, you would just be dividing by 1 and timesing by 1. So you're not actually changing the I. But if it's anything different than annually for compound interest only, not simple interest won't have any different compound periods, then we have to calculate our I and our N. So this is usually where I have students try to calculate I for the following situations. So I'm just going to check and see here, but I don't think I have any. Can I exit out? Don't think I have any students online. No, I don't. So we can probably go through all of these together, or at least most of them, so that we get some extra practice on calculating these. So these are pulled from the textbook, or sorry, the booklet that's usually given. So all we're doing is just calculating I. Sorry, I have to get back to my PowerPoint. So let's go back. Oh, I keep doing that, sorry. Okay, so for quarterly. So remember for I, do I multiply or divide? You can always go back and check, but my I is going to be my rate. So in this case for A, I have 0.05, and I'm going to divide by however many compounding periods. So in this case, it's 4. So I get 0.05 divided by 4. And this gives me 0.0125. For B, 5 3/4 is 5.75, right? 5 3/4, 5.75. We divide that by 100. So my I is going to be 0.0575, right? So I just divided this by 100. So 0.05, divided by what? So semi-annually means twice a year. So we're going to divide that by 2. And that gives me 0.028 0.75 as my I. For C, we have 6% monthly, so 0.06. Monthly is 12 times, right? So 0.06 divided by 12 gives me a new interest, or I, or a rate of 0.05. Yep, 0.005. For D, I have 4.2%, so bi-weekly. So bi-weekly, I said, was 26 times a year. So we have 4.2 as a decimal. Now you could divide before. You could take 4.2, divide by 26, and then divide by 100, but I like to put it in decimal form first. So 0.042. Biweekly divided by 26. Divided by 26 is, now you can keep this in fraction form if you want, but we get 0.0016. Let's just do 2. We're going to round this number to the nearest decimal place. So I get 0.00162 for my I. So that's biweekly. For E, we have daily. So we have 0.08. There's 365 days in a year. So we get 0.08 divided by 365. And that gives me 0.00022, we'll say. Or you could have done 219 if you wanted. As long as you have, at least 3 numbers. We call it significant digits, but or significant figures, but we want not just to have the zeros, right? We want to have a couple numbers in there, basically. So you can see here, I left 3 numbers here, just because these are very long. You could write them all. You could put 0.000219118. That's what the decimals, the calculator gave me. But I'm trying to keep, enough that it gives me the right number, but not too much that it goes off the page. Now, the more numbers you keep, the more significant digits, the more accurate your calculation is going to be. So this is just because you don't want to write so much on the page, but the more accurate would have been 0.000219118. That's the actual decimal. So probably should be keeping that just for accuracy, but if not, that's okay. And then for F, we have 12% annually. So it's just divided by 1. So it's actually just going to stay at 0.12. So it's not going to change. So I'm going to erase these. I think, whoa. I didn't know I could do that. I thought there was a way that I could erase all of it. Yes. Okay. So we'll do calculating N. So for A, I know my N is going to be the number of years. So in this case, it says monthly for 2 years. So 2 years times the amount of compounding periods. Monthly is 12. So my N is going to be 24. For B, we have 3 years and it's done weekly. So that's 52 weeks in a year. So 3 times 52 is 156. So my N is 156. C is annually for 36 months. Now, this is a little bit of a tricky part. So remember, when I'm calculating my N, it has to be in years. So in this case, I'm given 36 months. So let's first convert 36 months to years before we do anything. So 36 months, 36 divided by 12, right, is going to give you years. So 36 months is 3 years. So they're saying 3 years, but we need it in years whenever we're using this formula. So that's why this one was thrown in here. So 3 years, but now I still don't know is my N right. So it says annually. So it's just going to be those 3 years times annually, which is 1. So my N in this case is going to stay as a 3. Now, if it said semi-annually for 36 months, I would have taken that 3 and multiplied by 2. But we definitely can't have months. So let's look at D. D has something similar to that. Semi-annually for 30 months. So 30 months, we'll get that into years. So 30 divided by 12, it's not going to be an even number, or a whole number rather. So 30 divided by 12 is 2.5 years. Okay. Now I'm not done. My N has to include my compounding interest. So I have 2.5 years, but it's semi-annually, so twice a year. So my N is going to be 5 when I calculate my interest, when I use that formula. E, bi-weekly for 6 months. So let's first get this months into years. We need that in years. So 6 divided by 12 is going to be 0.5 years. Sorry, that's 0.5 years. So 0.5 years, but now I want to calculate my N. So I have 0.5, and now they're saying bi-weekly. So that's 26 times a year. So it's 0.5, which was my months into years, times 26 gives me 13 as my N. Sorry, just 1 minute here. I'm just trying to. Sorry, we're going to go to F. I had a student messaging me. Okay, it's daily for 3 weeks. So 3 weeks, well, we don't want that. So we know for every 3 weeks, there's how many weeks in a year? 52 weeks in a year. So we're just getting weeks to years. So 3 weeks divided by 52. So this is 0.06, we'll say, because 0.057. So 0.06 years. And they're doing it daily. So we had 0.06 years daily. Just move this out of the way. So times 365. So times 365 gives me some 0.06 times 3. 21.9. Now, I did round this number, so this is going to be rounded, but you get the idea. So we need to make sure it's in years first, then we can do our compounding periods. So this is the amount of time it's in. So either the amount of time it's invested or the amount of time that our loan period is. And then this is our compounding period. So this is how many times this money is compounded, which is usually means a reinvestment. Okay. Just gonna check again and see if I have anybody online. Nope. Okay. Okay, so example 3. We have Wayne bought a computer and he owes $3,000 to the computer store. They charge $7,000 and compound it quarterly. His payment is due in full in 3 years. So compound it quarterly. So this means it's So I don't know if I did a good enough job explaining compounding periods. But in this case, we're just going to look at the formula. But you can see that the compound, so with simple interest, it's over just the amount of years. But with compound interest, we have compound periods. So this principal is compounded 4 times a year. So this interest rate changes. So that's why it's well, the interest rate changes in terms of the compound periods, but also the amount of times it's reinvested. So that's why you're making money on that interest. This should have been B, but anyways, A. Wayne bought a computer and he owes $3,000. So they're telling us that my principal amount is $3,000. Then they're saying they charge 7% and compound it quarterly. So we know for interest, or I, we take 0.07 compounded quarterly, so we're going to divide that by 4. So 0.07, oops, divided by 4, that gives me 0.0175. Now N, this is for question A. So his payment is due in 3 full years. So, but in question A, it says, how much will he owe them in 3 years? So 3 years, but we know it's compounded quarterly. So I have 12 payments, or 12, like our N is 12 in the formula. So we did 3 times 4. So I'm going to pull up my formula here for compound interest. So it's P is 1 plus I to the power of n. I said my principal amount that was originally that I owe is 3,000. My I is 0.0175 and my n is 12. So when you plug this into your computer calculator, sorry, the question says computer, so that's confusing. Let's see here, we get 1.0175 to the power of 12 times 3,000. That gives me 3,694. So $3,694.32 is the amount that he will owe them in 3 years. So that's question A. For question B, it says how much will he owe them if he just pays them off in 1 year? So instead of, so my interest, so the question is, will my interest rate change, right? So, or will my I change and will my N change? So my P definitely stays the same. My I was 7% and it's still compounded quarterly. So in 1 year, it's still compounded 4 times. So my compound interest, or my I, stays at 0.175. My N, though, is the amount of years. So now we're saying we're only going to pay it off in 1 year. And it's still compounded quarterly, but my N in this case is just 4. So up here we had 3 years. So my N changed quite a bit from 4 to 12. So we're using the same formula. So we have 3,000. My I did not change. Oh, I don't know what happened there. A second here. So we have 3,000, 0.0175 to the power of 4. So when I plug this into my calculator, I get $3,215.58. So if he pays it off in a year, he'll save himself about $400 and something, right? So probably better to pay it off earlier than later. Okay, so that's the answer for question. So this is question A. Whoa, sorry, I don't know what's going on with my pen here. Question. Okay, so sometimes we're going to be asked, just like we were in simple interest, to calculate the principal, or calculate, in simple interest we were asked to calculate N or T, or sorry, in that one it was T or R. But if we want to figure out how to calculate the principal, it's possible to calculate the principal, and all we're going to do is rearrange this formula. So this is my formula for compound interest. If I rearrange it to isolate P, I'm actually just dividing both sides by this whole thing. So the formula I end up being able to use is P is equal to the amount over 1 plus Ri to the power of N. So this formula, I have a formula sheet that's attached to the assignment, but you don't have to know how to rearrange this. It's just explaining to you where that formula comes from. So let's look at an example. So we have, how much would you have to invest for 5 years at 10% compounded semi-annually to receive $5,000? So the tricky part when we see these questions, is to figure out what are we being asked. So it's saying, how much would you have to invest? So if we're, for either it's borrowing or investing, that's our principal amount. So they're asking us to find P. Our T, or our number of years, is 5. 10% is our rate, compounded semi-annually. So this means 2 times per year. So 2 times. To receive $5,000, so the amount I'm receiving is 5,000. So we're given amount. So let's write down everything we have. We have an amount of 5,000. We have our N, we have to calculate. So it's 5 years. It's compounded semi-annually, so 2 times a year, so my N is 10. And then my I is 0.10, because we were given 10%, divided by 2, because it's twice a year, semi-annually, so 0.05. and I'm trying to find my principal. So that tells me that I'm going to use this formula. So my amount is 5,000 over to the power of n, which is 10. So we get 5,000 over 1.05 to the 10. And you can punch this into your calculator either using the fraction key or the division key. And you should get $3,069.57. This is a comma, sorry. I don't know why I used a comma there. I didn't have to, but. So this person would have to invest 3,000, let's say 3,070 really, but if this is a specific amount they would have to invest if at the end of 5 years with this interest rate compounded semi-annually, that this would earn me $5,000 by the end of that term. So that's how much, so that's calculating P. So it's really cool because you can actually use this a lot in your banking and your savings accounts, depending on, each bank is different and each account's different. Each investing portfolio is different. So this is by no means teaching you everything you need to know about that kind of stuff, but it does allow you to see how compound interest is significantly more beneficial than simple interest. And what we'll get to on Wednesday is what we call annuities or future value. And that's often probably the one we use a lot more often. And that just basically means like lots of people take off a certain amount per paycheck, right? So instead of just giving this big lump sum investment, which we often don't usually have, like how often do you have just $10,000 or $5,000 to put into a savings account or an investment account? So often what we'll do is we'll take off $50 a pay period or every 2 weeks, or we'll take, we'll invest $100 a month. And then we can use a specific formula that we'll learn on Wednesday or whenever you watch the next video about how we calculate that and the difference that has in terms of investing. So that's the way that most people invest, just because it's a little bit easier to use. So the extra practice, so that's the end of today. There's a lot more examples in the compound interest unit. So this entire so simple interest, compound interest, and annuities, or future value it's also called, they're all in the personal finance booklet. So this is the second section we covered today. There's lots of examples. There's also a practice unit test, or I think it's called a practice unit test, or it covers all of the compound interest stuff that we've just covered. So you can try to go through those questions and determine if you can figure out, when am I being asked to find principal amount, when am I being asked to find just amount. I even think they might have some where you calculate n, I can't remember though. So that's more examples, more questions to try if you have any more questions. If you have any questions for me, let me know, or your teacher. We're always here to help. And the next lesson after this will be, like I said, it'll be the future values annuities section. And then we will be done everything we need to be done for this, this unit, which is personal finance, which is assignment 3. Okay, great. Thank you for